we discussed signed area. What do we do with integration in general? So yesterday, I mean previously, in a previous video, yesterday we discussed signed area. What do we do with integration in general, known as indefinite integration? What do we already know? So integration in general. Instead of having, say, oops, try again. The integral from from 0 to 1 of x dx, instead of doing that, and we can find what this it gives us a specific number, which we could figure out because it's a line. Indefinite integration is saying, okay, we have x squared, so that's our derivative. Think of it as our derivative. Our derivative is x, sorry. Where did it come from? So whose derivative is x? The derivative of 1/2 x squared would be x. So this is, we were moving this direction. Now we're going to work on moving that direction. So let's see what we got. Antiderivatives. A function f whose derivative is f. Now notice we have a big F and a little f. So the antiderivative is any function, big F, whose derivative is little f. So on the previous page I said 1/2 x squared. Couldn't I have picked 1/2 x squared plus 42? The derivative of that's still x, right? So an antiderivative is any function f whose derivative is little f. Indefinite integral, slightly different, is defined to be the family of antiderivatives. So little f, we integrate it, we get big F plus c, where that c is any number we want. 42 was my example, but any number you want. So evaluate each indefinite integral. So take a moment, pause the video, and do all those. And I will talk you through them. Did you pause it? Hope you did. So that's going to be x squared with a negative 4. And then that's going to be x to the 5th. So I have 1/5, so I need 4, because 4 times 5 is 20. Oops, I forgot plus c. Plus c. That one looks scary, but let's go ahead and divide. So that's 3 over x squared. So 3x to the negative 2. Minus 10 over x cubed, so 10x to the negative 3. So that's going to become, careful because you're adding, x to the negative 1, so negative 3. And then x to the negative 4 and positive 2 plus c. Same idea with this one. So that's negative 4x to the negative 2. And then that's negative 10x to the negative 3. So that's going to become x to the negative 1 with a 4. And then x to the negative 2. Oh, I did that wrong. I got to fix that one. That was silly of me. With a 5. I just paused because I messed this up. That's the classic mistake. 2 there and 5 there. Beautiful. And plus c. And then 5 over secant is the same thing as 5 cosine x. Negative 5 cosine x, well, negative cosine x becomes sine x with a 5. And then 4 over sine squared is 4 cosecant squared x, and that's cotangent x with a 4, but a negative, right? Because it's negative cosecant squared. If you don't believe me, build it. Oh, look, there they are. We did it. And you should try these. So pause the video and you should try these. Some of these are trickier than others, but give them a shot. Did you pause? I'm going to go to the answers. Don't ruin it. Oh, you ruined it if you didn't pause it. And then this is starting for our next one. So look at this. Pause this video. Think about what's going on, because this is our future right here. This is our future. As a note, I remember that I had an issue here, so y equals 2x plus 3 is that function. So careful there. But think about that.